Let's do an example of how to write the name of a multivalent ionic compound if you know its formula. It's very similar to how you would do the name for a binary ionic compound, except we have to include the charge of our metal in Roman numerals in parentheses. The way you're going to know you have a multivalent ionic compound as opposed to just a normal binary ionic compound is by looking at your metal element, in this case it's Fe, and seeing where it is on the periodic table. So Fe is element number 26. You look on your periodic table, that's in the middle of your periodic table, that chunk in the middle, the transition metals. So it is multivalent, so we're going to need the Roman numerals. So the way I like to do this is I start by separating the two, your metal and your nonmetal, and we're just going to make a list. Now I know that I have 3 Fe's and 2 phosphorus, because that's what the formula tells me. This 3 right here tells me I need 3 Fe's, and this 2 tells me I need 2 P's. So I know that I have 3 Fe's and 2 P's. Now I need to figure out the charge on each of these ions. Your nonmetal, your phosphorus, will always have the same charge. If you look on the periodic table, phosphorus has 5 valence electrons, which means it's going to have 1, 2, 3 empty spots to fill. So it's looking to take 3 valence electrons. That means it's going to have a charge of -3. This is true of each phosphorus that you have. So overall, you have a total negative charge of -6. Now remember, when you're writing your ionic compounds, that your positive and your negative charges have to cancel each other out. So if I have a total negative charge of -6, I have to have a total positive charge of +6. Now to figure out the charge on each of your Fe's, we have 3 of them. We have to divide the charges equally. So if I have a total positive charge of +6 and I have 3 Fe's that I have to distribute that charge to, that means that each Fe has to have a charge of +6.